In this video, I'm going to show you how to use the Intel Realsense camera and publish and subscribe to an image that you're sending over ROS to. The first thing I want to do is I want to create a workspace for my ROS2 distribution. Now I'm using Humble for my ROS2 distribution, but I've used the same method on Galactic and I've used it on Foxy. So what I want to do is in the Humble documentation, I want to just use the documentation, the code that they have to actually create my directory. So first things first, I create a terminal. Now I use the terminal terminator for this development. And so I can get that by sudo apt-get install and terminator. Now what I like about terminator is that I'm able to split these tabs vertically and horizontally. So I can get 4 or more terminals in the same display, which is very useful, at least I feel, when I'm using ROS. So now that I have my terminal, the first thing that it tells me to do is source my setup.bash of Humble. Now for me, this is a little bit different. I can run this and it will source, but if I look at my .bashrc file, the way I do this is I have my Humble setup sourcing every single time that I open a new terminal. So I don't need to run that particular code. It runs every time I open a terminal. So that's one shortcut that you can have rather than having to source this every time. Next, I have to create a new directory. So this is my home workspace. So I'm going to create a directory. So I'm going to make a directory that's going to be YouTube. Let's call it YouTube ROS. And I'm also going to make my source directory. Now I'm going to just move into my YouTube directory and I'm going to run colcon build. When I do this, now my directory has all of these different files in it. It has my source, my build, my install, my log. It has all of these different folders. So that's good. The next thing I want to do is I want to make a new package. So I don't want to follow anything else on this tutorial because this is just going to have me clone into a GitHub over here. So I want to go to making a package and I'm going to be running everything in Python. So to create my package, I need to go into my source directory. So I can go to cd source. And here I'm going to create my package. So I'm going to have ROS2 package create. I'm just going to call this YouTube robot. So this is my package name right here. I do things in a little bit different order. And I am going to set it up for Python. So this is going to be build type meant Python. Okay, so it creates all of these folders and it looks like it created correctly. If I look at this, so I can cd into my folder, I'm going to have all of these different files and folders, which means that I was actually able to build this correctly. So right now, everything is set up. My ROS2 workspace is set up and I'm going to get ready to code my Intel Realsense. What I need to do is actually write my 2 files that I need. So in my YouTube robot, I want to change my directory into my next YouTube robot directory. And I want to create 2 files. So I'm going to make a file touch. I'm going to call this Intel pub.py and touch Intel sub.py. Now, while I remember now, I'm going to change these permissions. I'm going to make these both executables. Change mods plus x Intel sub.py. And this is just going to make my life easier a little bit later on down the line. So let's write my publisher first. Now, with my publisher, So I use Sublime and Intel Pub. The first thing I need to do is I need to import some ROS packages. So rclpi.node, import node from rcl.node, import node. Okay, then from sensor message dot message, import image, and from CV bridge, import CV bridge. Then I want to import CV2. I want to import Pi Realsense as RS. Now, this is really cool. This idea is going to work for both the Intel Realsense camera and it's going to work for regular webcams that you have. The only difference is going to be how you make the connection to the actual camera. So we'll see later when we make a connection to the Pi Realsense that if you made it a video capture instead, everything else just works. So that's sort of cool. All right, so here's everything I need. Now let's make my main function. So if name is equal to _main, then I'm going to call my main function. Let's define my main function. Its arguments are going to be equal to none. And now we just do a little housekeeping with ROS. So we're going to initialize rclpi .init with arguments is equal to none. Then we're going to have my Intel publisher is going to be Intel publisher. So I need to create this class right here, and I'll do that in just a minute. Then I say rclpi.spin. This Intel publisher is what is going to get spun. So this gets spun here. That means it just runs. And then after we're done, what we're going to do is we're going to say Intel publisher dot destroy node and rclpi dot shut down. Okay, so this is just sort of standard ROS things that we put into main, and now we're going to actually create our publisher. So this is going to be a class. This is Intel publisher. Its argument's a node, and now we need our init function. It has an argument of self. The first thing we do is we call super dot _init, and we're going to give it a name. I'm just going to call this Intel publisher. Now this name right here is going to be the name that's displayed when we're sending error messages, info messages, warning messages from this node. So that's whatever name you want to put there. And then I want to say self.intel publisher RGB is going to be equal to self.create publisher. And here we're going to take an image. This is the data type that we're going to be sending. We're going to be sending an image. Other types you can send strings, ints, floats, arrays. So your custom messages. But we're just going to send send an image. It's going to go on RGB. The topic is going to be RGB frame. Again, you can make this called anything you want. You just need to know that that's where the info is going to be stored. And I'm going to make a queue list of 10. So that's what we have. Now, how does this actually send a frame? Well, we create something called a timer. So my timer period is going to be 0.05 seconds. And then what the timer does is every time the timer ticks, so every 0.05 seconds, it's going to run the code that's in a callback. So we have a self.timer is self.create create timer. We want the timer period, and we want self.timer callback. Now this function we also need to write. And so every time that we create the timer and we have a callback, what happens is the timer actually hits the callback, and that's when we push the frame on the actual topic. So we want to try to create this timer, and we also want to try to create the connection to the camera. So this is where, if you're not using an Intel Realsense, you can put your video capture, if say you're using OpenCV, and it will work the same. All right, so self.pipe, self.config is rs.config, self.config.enable stream, rs.stream.color, because I want my color stream. I'm going to stream this 640 by 480. The format is going to be rs.format.bgr8 and 30 frames per second. So this enables my stream. Okay, and then I want to start my actual camera. Now we can accept my exception as E. And what we can do here is we can say, all right, let's print the error. And we're going to say self.getLogger.error. Here, the good chance is my Intel Realsense is not connected. And this will display in a nice red. So if we'll try that, we'll start with it not connected, and we'll see if we get this error. That just tells me my Intel Realsense is not connected. Okay, but if it is connected, we have to go and we have to make this timer. So we called this timer callback. And what this timer callback is it actually grabs the frame. So we're going to have frames is equal to self.pipe.wait for frames. Then my color frame is going to be equal to frames.getColor frame. We need to change this color frame into a color image. So np.asAnyArray color frame get data. All right, so we get the frame, we get the color, then we get the color frame. Then we have to put it into a NumPy array, which is what OpenCV uses to display the image. And then here we'll have self.Intel publisher. What did I call it? RGB. So it's this. And then we're actually going to .publish. We're going to publish this. I actually need to have something else up here. So here I need to have a self.brRGB is CV bridge. So I need to create a bridge that will convert between the NumPy, the OpenCV format, and this message image right here. So this bridge just bridges the two message types. So we want to have this bridge. We want to publish this image, but we need to use this bridge. So we publish CV2 to image message color image, right? So here's my bridge. I'm using this function on it that goes my CV2 to an image message, and this is what I'm changing to an image message. So I think this should be good, and then we'll just do the same thing right here. And we'll just say it won't be an error, it will just be an info. And we will say publishing RGB frame. Okay, so now this should work. Hopefully I don't have too many syntax errors. Next thing I want to do, I need to change, I need to go up a level here. And I need to play with this setup.py file. So setup.py. In this setup.py file, I need to go into this console scripts. And in this console scripts, I need to create an entry point of this Intel publisher that I just used, so I can use ROS2.run. I can always run this. We can test it right now, actually. I can always run this here and just say Python 3 Intel pub, see if there's any. Okay, so this tells me there's a problem here. So this is Pi Realsense 2. And it seems like it's sort of running right now. There's a problem, but I want to be able to use ROS2 run. So this is going to be Intel pub. So this is going to be equal to my YouTube robot dot this file name right here, Intel pub. And here's my main file. So it's pointing to this function. So I can save this. All right, next, let's go to the main directory. I'm going to do colcon build. I'm going to do packages select my YouTube robot. Then I'm going to do symlink install. It's not necessary, but this makes your life a little bit easier because it allows you to create that symlink, and when you make a change in your Python file, you don't need to recompile. It just sort of automatically works. That's why it needs to be an executable. Okay, so now the part I always forget is I need to actually source my install file or my setup.bash. So if I do ROS2 run, and I want to try to use right now my YouTube robot, and I'm tabbing autocomplete, it's not there. So I need to do source setup install source install setup.bash. And now if I do ROS2 run with my YouTube robot, it auto-completes. And what I have is my Intel publisher. So I can do Intel pub. And right now nothing's working. But it is also not, it's not installed. So, it's not plugged in. So let's plug it in. Maybe there was something else. So I plug it in. I run it now. And now I'm publishing my RGB frame. So my error just isn't working right now. Let's see if we can figure that out later. But I am publishing my RGB frame when I plug this in. Okay, and it's telling me that it's my Intel publisher publishing RGB frame. So what's good about that symlink install is, let's say I make this a lowercase RGB and I save. Now I can run this again, and instead of the capital, it is a lowercase RGB. So I didn't need to rebuild everything. Okay, so I have my publisher written, and I'm going to go on and make my subscriber. So the other thing was I actually just wasn't waiting long enough for this no device connected to actually pop up. So if I unplug my Intel Realsense and I try to run it, it just takes a little bit of time for it to try to make that connection with the Intel Realsense. But if I just wait long enough, what I'll get is this Intel Realsense is not connected. Now, if I switch the order of this timer right here, and I'll only start the timer if I was able to start, I probably can get rid of most of this other error message. So let's try this again. And yeah, so no device is connected. Intel Realsense is not connected. And I can get rid of this problem where I was trying to wait for a frame before I actually started my device. So let's go and let's go into CD, my source, my YouTube robot, and let's write my Intel subscriber. So my Intel subscriber is going to be the same thing, except all I'm going to be doing is waiting for a image to pop up. If I get an image, display it. So again, we want to import RCLPy. We want to, from RCLPy .node, import my node from sensor messages.message, import image, and from CV bridge, we want to import CV bridge and import CV2. Okay. So let's do the same thing from the beginning. If double underscore name is equal to main, then I'm going to call my main function, define main, and it's going to be the exact same setup as before. So my arguments are going to be none. I'm going to have rclpi.init. My args are equal to args. My Intel subscriber is going to be equal to Intel subscriber, and then rclpi.spin this Intel subscriber. I apparently can't spell subscriber. And then we'll have it copied. That will destroy the node, and then rclpi.shutdown. Okay, so I need to create this Intel subscriber right here. So this is a class. It's going to be Intel subscriber. Going to have node as an argument. So def init self. Now this super init is going to have a name. I'm just going to call this Intel subscriber. Subscriber. Okay. Now I just create my subscription. So self dot subscription RGB is going to be equal to self dot create a subscription. The message type is going to be an image. I'm looking for RGB frame, and it's going to be, I'll call this RGB frame callback. Okay. So this is the callback. So I created a subscription. Whenever it triggers, it's going to call this RGB frame callback. So I also want a self.bridge for RGB is equal to CV bridge. Okay, and now we can define my RGB frame callback. And it takes two arguments. It's going to take itself, and it's going to take data. Data is where the image is actually going to be living. So now what I'm going to do is I'm going to say self.getLogger.info. Oh, I'll do a warning just to show you what a warning looks like. But so warning should be yellow. But I'm going to say receiving. I just can't spell tonight. RGB frame. Okay. So then my current frame is going to be equal to self dot the bridge that I created, bridge RGB dot, it's an image message to CV2, and that's what my data is. So this is the data that's an image message to CV2, and then all I have to do is CV2.imShow. The name is going to be RGB, and this is going to be the current frame. Okay, then CV2.wait key 1, and this is what I need. So I create a subscription. I created my bridge, and then whenever I get an RGB frame, I'm just going to show you what the warning is, but I then convert it from the message to the CV2 and then display it. So we need to go back into setup. We need to go back into Intel sub is equal to YouTube robot dot Intel sub main. Save it. So we can do the colon build. Oops. Forgot a comma right here. That's probably the error. Yep, looks like that was the error. So you need a comma after each of these. And now let's see. Do I need to source this again? ROS to run YouTube. And I have my Intel pub and my Intel sub. So let's do my Intel pub first. Intel pub. Let's make sure I plug it in. So I'm publishing my RGB frame. Let's split this vertically right here. So when I split this vertically, it's everything's sourced already. So ROS to run my YouTube. I guess it's not sourced already. So source install setup.bash ROS to run YouTube robot and then Intel sub. Okay. Oops. Okay. So I have a problem with my node name. Where's my node name? Probably right up here. Intel subscriber. So that's going to be like a 10 somewhere. So I must have forgot that. Oops. So it's telling me I forgot this quality of service, which is that Q. So I need to put in a 10 or whatever I want. Current frame is not defined. Did you mean current frame? Just can't spell tonight. So current frame. Okay, now should be working. So now I get my RGB image. I get it as a warning because I said to put it as a warning, and that makes it yellow. So what I have is I'm sending my frame on ROS over on my publisher. I'm receiving it over here on my subscriber. So there you have it.